Hello, hello, hello. Hi, and welcome. This is Ask the Expert, Build Intelligent. This is Build Intelligent Microservices with Azure Container Apps. We have a bunch of experts from the Azure Container Apps team here with us, and we can't wait to share demos with you and talk to you about some of the new features that are coming out. So have your questions ready and give them to us on the chat. I'll be watching, and we would love to have you be really interactive with us. But without further ado, let me first start by having our experts introduce themselves, starting with Daria. Daria, do you want to go first?
Hi, my name is Daria Grigoriou. I'm a PM manager working on Azure Container Apps, and I'm really happy to be here today and talk to you about Azure Container Apps and microservices.
And next, we have Carrie.
Yep. Hello, everybody. I'm also a program manager on the Azure Container Apps team. Very excited to be here and talking with you guys today.
And we have Sophia Carpenter.
Hi, I'm Sophia. I'm another PM on the Container Apps team. Love to talk about Container Apps and show off the stuff that we have.
And last but not least, we have Anthony Chu.
Hey, I'm Anthony, also a PM on the Container Apps team.
Awesome. So we have a packed agenda for you today. We're going to start off by having a quick introduction to what Azure Container Apps Compute does for microservices. Then we're going to have a couple of really cool demos that you should absolutely stick around for. But before we get started, Daria, do you want to tell us a little bit about what Azure Container Apps can do for microservices?
Yes, absolutely. And as part of that, I also want to show you a little bit of what this actually looks like. Let's make sure we have that. Azure Container Apps is essentially serverless containers for apps and microservices. The platform was designed specifically to help with app migration and modernization for especially cloud-native apps. So you can bring an existing app to the cloud. Everything is containerized, so it's super portable. And then you can expand from there, as well as build cloud-native microservices as well. So because we know that we're designing for migration, modernization, we're enabling microservices, the way that we build our compute is to be very flexible and make sure that we acknowledge the different components of your microservices and the different needs of those components. So the way that we structure Azure Container Apps is by creating an execution environment, which is the Azure Container Apps environment. And that has a common execution, networking isolation, observability boundary for all of the apps or components in the microservices. And not only that, but when we looked at the different compute needs of those components, we know that some of them may not have very specific needs other than a bursty, event-driven type of pattern, but they're okay with generic compute. And some of those components may need to have specialized compute. They might have specific memory needs. And so we built workload profiles. And I'm going to show you a little bit how those are structured. So in the Azure Container Apps environment, we can have multiple apps. And here you can see a few of the apps in one of the demos that we'll be showing you. And all of these apps are mapping to different workload profiles. By default, every Azure Container Apps environment is enabling the consumption workload profile. You don't have to do anything to create that. But we can also add some specialized compute as different workload profiles that are available in the environment. And you can actually run multiple apps on the same workload profile. Just think of that as a pool of resources that you have available to map your apps. And then we know that it's really important to be able to grow your solution over time. So of course, you can go and define new workload profiles at any time and add those to the environment. And these are some of the options that are available in terms of dedicated, which gives you the opportunity to have a dedicated control plane as well. in addition to that, it gives you the opportunity to have specialized compute, like we mentioned, to meet the different resource needs that your different applications might have. If we look at how this maps from the app perspective, this is an Azure Container Apps app, and we have multiple of them in the same environment, potentially. And here we can see that we've mapped this one to a dedicated workload profile. And we have the ability to change the workload profile that we're running an app on based on the ones that we have defined in the shared execution environment. It can be consumption, and consumption is ephemeral general purpose compute, scales all the way to 0. So it's basically your serverless containers. Or you can have dedicated, that gives you a dedicated control plane. And it also gives you the ability to specialize your compute depending on the specific needs of your app or apps. So now that we've gone through these concepts, I want to draw your attention to our documentation where you can find all the different workload profiles we support, as well as more information about these. And I would invite you to try them out if you haven't already. So if there are questions, we're happy to address them. And I'm going to hand over to Carrie to walk us through the demo that we started observing right now.
Yep. Thank you, Daria, so much for that great introduction into Azure Container Apps and workload profiles. Workload profiles are super great for intelligent applications because you can have different sizes of compute for each of those different microservices you have within your application that you built. So today's demo, we'll be walking through how you can leverage Azure Container Apps to build intelligent apps, and we'll be discussing along the way how ACA supports microservice best practices, scaling, observability, and more. So the application we have here today is a digital content platform where customers can rely on generative AI to create content and images. We'll focus on an example where we generate an image through DALL-E and see how microservices hosted on ACA can simplify delivering this solution. So starting off, this app is comprised of 3 different microservice components. There is a front end where customers will be able to interact with the digital content generator and input their own prompts. There's also a middleware API controller, which will send and receive prompts to and from the content generator app through Service Bus topics, as well as store and retrieve the images in Azure Blob Storage. Finally, we also have an AI content generator application powered by Azure OpenAI's DALL-E. These 3 different apps will be deployed to the same Azure Container App environment, which, as Daria mentioned, means that they will share an execution, isolation, and observability boundary, but allows apps within it to really easily call other apps within the environment. In addition, we leverage Dapr, a portable event-driven runtime that is an entirely open source CNCF project, which simplifies the creation of microservice-based applications. Dapr's APIs seamlessly build in industry best practices for building microservices with your preferred language or framework. In addition, for this application, we leverage Dapr to enable app intercommunication and activation through things like Dapr's Hub Sub with Service Bus topics. Dapr also enables other features such as discovery and resiliency in this case. Dapr is also incrementally adoptable, so you can use as many or as few Dapr capabilities as you need. And in this case, we just focused on how we use the Pub Sub API to enable app intercommunication and activation. We're also going to be using Dapr's Azure Blob Storage bindings in order to store and retrieve our generated OpenAI content. So now we've taken a look at the architecture and what the app actually is. So let's go and take a look at what that looks like in code. So here we have the application in our VS Code. And if we go in here for apps, you can see that we have the AI content generator, the API controller, and front end, all the 3 different pieces that we just talked about. Each of these are standalone applications and will be deployed as different apps within the container app environment. And let's go see an example then now of Dapr being used in our local code. So what we want to show basically is how simple it is to use Dapr to create, like, for example, a storage blob and send that message over. It's only a couple of lines of code, and this really streamlines your development. What's really cool also about working with Azure Container Apps is that it's fully integrated with things like Azure Developer Tools. And And what that means is that just with your local applications, you can add in some bicep files, and getting everything in your environment, your apps, your infrastructure deployed is as easy as just running a simple command like azd up, and it will deploy everything. So now let's go take a look at that in the portal to see all those resources deployed already. azd up takes a little bit of time to run, so I ran it a little bit beforehand. So now, if we go to the portal, we can see that we have all of these different resources that we had already created with that azd up command before. So we can see we have our 3 different applications. We have checkout, front-end orders, so API controller, front-end, and also the AI part of the application, as well as some other resources that were all deployed using that same azd up command. So we have things like our service bus, our OpenAI instance, as well as our storage account. So now let's go take a look at this application actually in action. But before we do that, and I've already opened these up here so that they don't take time to load, but let's go to our checkout first. And how are we going to know that our app is actually running? Well, we have some really cool observability tools that are available here, one of which I will show right now, which is log streaming. And log streaming is really cool because it will give us some real-time logs into our container app. So let's go and open up our application, and we're welcome to Kotozo Digital Content Generator. Let's get started. So let's generate some content. Let's do something like a beautiful summer day. Oh, if I could spell. Hopefully you're smart enough to know, but okay. And right now, an image should be being generated. And once this image is generated, we'll get it back, and we can also go to My Content to retrieve all these different images that we create from our blob storage. Now let's go to our checkout app. So you can see here now that we do have enter image retrieval. So we just went and got all of our different images, and you can see all the logs that we have in real time, showing that our application is working, going through the different steps of our app executing. So with that, that's a really quick demo of the app. And I'm going to hand it off now to Sophia to talk a little bit more about scaling, other observability tools we have, as well as revisions in our deployments. Thank you.
Yeah, before Sophia takes over, I'm just going to give a shout out to the chat to say, please do keep your questions coming if you have them, and we'll try to get to them at the end of this session. Go ahead. Sorry.
Definitely, no problem. So yeah, I'm Sophia, and I was going to talk to you guys about some of the observability parts. So actually, why don't we go to the app, and then if I want to generate content, let's say my generation is a cat that zooms, because my cat has zoomies in the background. If there's weird noises coming from me, that's probably her. She has a lot of energy right now. And before I click create, I want to go to, let's go to the orders, or checkout, yeah. And go to the logs, log stream, because I want to show the logs showing up live as we generate content. So right now we've got a log stream going. It's doing its thing. And so now when I create this image and I click create, oh, and hey, it's got the beautiful summer day from Carrie's. So let's create a new one. It's being generated. And this will start, see, it's trying to send to storage, sent to storage. It's going through and doing all of the work. This is my new revision. It has all of the different little tags and such that from Carrie's code. So as it's being generated, you can see in the logs what the backend is doing. So it takes a minute or two to generate the content. And actually, it one of the things that we could do to help it generate a little bit faster for future ones is to look at the scaling that's going on. So while this is going, I'm going to put it back into, oh, no. Let's put it back into here. There we go. So this is checkout. And Carrie, remind me, is it checkout or orders that is the back end?
Yeah, so checkout is the API controller, so it handles all the messaging between the services. But then if you want to go see like the actual, applications generating the content, that's going to be orders. Yeah.
Perfect. Thank you. So if I go to Logstream in orders, you can also see the details from the smart AI stuff, and it's talking about like it's stuff is created, it's succeeded. You can also do the Logstream in here. So let's look at our revisions. And right now there's this one latest revision. So a cool thing about container apps is that if you want, we will handle updates for you. This is what we call single revision mode. So if you make an update, say you want to change the scale rule or something, and you go through and change the scale rule and make this update, then we can we'll make a new revision for you and wait for that revision to be completely produced and ready for content before switching over the traffic. So if I was a customer doing this and looking at the app and typing in content, then as the customer, I would never see any downtime. So we try to do zero downtime deployment. And we do that with the revisions and making sure that that we will switch traffic over for you once your new revision is completely up to date, so that you don't have to handle it yourself. And so right now, our scale and replicas for orders is 0 to 10. And I could say that I want to edit this because I don't want any cold start. So right now, if there's no traffic going to our app, then we can scale it down to 0. And this is to specifically the backend bit. Each of our different apps, the checkout and the front end, can have different scale rules. So the front end, since it's just the HTML, the front-facing thing, it really doesn't need much, like many replicas. So we can just keep it at 1. It doesn't really need to scale. It can handle whatever traffic we get it. Checkout might have a different one, but then the back end, because it is our because the back end is the AI portion of our app, we really want it to be able to scale up quickly. There we go. So if we wanted to change the scale rules, currently it's got a min and max replica of 0 to 10, and then this is a topic-based scaling. So this is a scale rule based off of Azure Service Bus. I'm not going to mess with that one, but I will move the minimum replica up to, let's say, 2. So there's always going to be 2 replicas at any given time. If I create, and I need to go back to, oh, and my cat wants to be involved with container apps. This is Goma. She apparently wants to be part of the live stream. And in any case, if we go to revisions now for the orders, and I refresh this, it should have had 2 of them. Was I on a different one? Oh my goodness. In any case, the scale rules and such can get changed. Let's try this again, just because it was in a little bit of a wonky spot. I'm gonna move my cat away. There you go, Goma. So I'm going to go to scale, move it up to 2, and create. Oh, and there's a really great question here of what is revision mode single? Hassan, that's an awesome question. And there's lots of information in our docs about single revision mode. It's pretty much that we are handling updating revisions for you. So when you make a new revision, here we go. When you make a new revision, we will handle all of the provisioning of the new revision, scaling it up before we switch traffic to ensure that your app doesn't have any downtime issues. So you can kind of see as it's just going through, it's provisioning and running, and it takes a little bit to delete the old one, but it ensures that in no case will the actual app be it will always have traffic pointing to one revision, and that we know that that revision is healthy and working. Yeah, it's part of it is for blue-green deployment. Yeah. Cool. And with that, I think we've fiddled around with this enough. We have another fun, exciting demo for you from Anthony about jobs.
Yeah, and before we move to Anthony, I was actually going to ask you and Carrie, because if I'm not mistaken, you mentioned that this is equipped so you can actually deploy the whole thing with AZD as well. Do you, Ben, have a repo with a template that people can actually go try out? Or would you be likely to publish them? We can send the link out to folks later. The sample.
We don't have one that we can share right now,
Okay.
but we can take a look at seeing if we can get that out for you.
I think it would be a great addition to the gallery. But I'll let Anthony take it away.
Alrighty. So what Sophia and Carrie showed us so far has been a UI for generating some images, but we can actually probably take that a little bit further. So one thing that we thought we would build is how about we create a blog platform, but instead of me doing all the work and typing up the blog posts, we just tell ChatGPT or basically GPT and OpenAI to do it. And then as well, within the blog article, let's embed some pictures that are generated by DALL-E. So this is what it looks like. This is the end result, and I'll kind of show you pretty quickly how to build it. So here you can see that we've generated a delicious chocolate cake recipe. I have not tried it, so I'm not sure if it actually works, but it looks reasonable. It's got, I don't know, chocolate cake-like ingredients in it. And then also it embeds some images within the article itself. So let's see how we can build something like this using Azure OpenAI and Azure Container Apps. So Carrie and Sophia already kind of showed you the image generation part of it. So and what they did was when they generated the image, they're actually doing it synchronously within a container app. So you're basically making a request to a container app. The container app behind the scenes is calling out to DALL-E and then generating the image. But sometimes you want to go and kind of have something run for a little bit longer, maybe asynchronously. In this case, the generation of the blog post as well as calling out to DALL-E to generate some images can take something like 30 seconds, maybe a minute. So this is ideal for a feature in container apps called jobs that allows you to kind of run asynchronous workloads in the background. So it's not actually consuming resources, and you kind of just wait for it to finish. And then and then after you're done running a job, the container actually goes away, and you only pay for the time that the container is up running your job. So I'll quickly kind of show you what the job looks like as well as the architecture. So it's a very simple Python script that we put together. So what we're doing is that we're it's just a script. So and we put it into a container, and when it starts up, it's going to look for an environment variable called topic, and then we will go ahead and call Azure OpenAI to get GPT to generate us a blog post about the topic. And then we're like, well, let's make sure there's a catchy title, use Markdown, and the article must include a few images that have alt text. And then we're going to go ahead and call it. And then when the article comes back, all I'm doing here is I'm just parsing it for image tags. And then for each of the images, I'm taking the alt tags, the alt tag, and then passing that off to DALL-E, and it's generating the image. Yeah, so now I got that deployed as a job. So quickly, this is what it looks like. So currently, we have the front end app and the back end API, a lot like what Carrie and Sophia showed us earlier. And they're talking to each other using Dapper as well, and in the images and the blog posts are being stored in Azure Blob Storage. And I'm going to deploy, and I've already deployed that script we just saw as a job in Container Apps. And then I've also deployed a front end for administrators of my blog post, so basically authors to the blog post, although really AI is authoring the blog post. But for someone to come in and kind of enter a topic and then use that UI to launch and basically run a job. So I'm going to go ahead and quickly show you, because I know we're running out of time, how that works. So I'm going to go over to my admin front end, which is just deployed as another container app. And we can also put this behind authentication as well. I didn't. So I probably want to hide this after the fact so people don't come in here and start generating blog posts. But for now, let's do that. Let's see. Let's go things to do in New York, because I know Nitya is in New York. I'm going to go ahead and submit. And behind the scenes, what it's doing is we're actually going to use Azure Resource Manager API to start a job execution. So while that's running, I'll quickly show you what that code looks like. So that we wrote in Node, and we're just pulling in the Azure Container Apps SDK, and with a couple of lines of code. The main line is here. I'm basically starting a job. And here before it, you can see that I'm actually setting the topic to what I passed in earlier from the UI. And that's all it takes to kind of kick off the job. And then I have another endpoint here where I'm actually using to query the status of the job, which is what we're seeing on the screen there. And hopefully within a few seconds, this is going to complete. But this is one of the good things about a job. So if this happens to take longer, if you want to kind of generate an even longer article, this could take a few minutes, maybe even longer. And also for things that don't call to APIs, things that require, a bunch of CPUs or maybe a lot of memory that you probably don't want to run within a container app that's running a web app. We can do that within a job. So this is actually taking longer than when I tried it maybe 10 minutes ago. So hopefully it does work. Maybe we can leave it up on the screen and kick it over to Nitya to see if we have anything else that we want to cover.
Yeah, just a quick question, Anthony. Can you also schedule jobs? I'm guessing you can, right?
Yes, that's a great question. So there are 3 ways to kick off jobs. What I've deployed here is what's called a manual job. So you can actually go to the portal and click a button to run it. Or in this case, I'm using an API to start it. Yeah, you can definitely do scheduled jobs. That's a very popular one. And you can also do event-driven jobs. So if you want a job to kick off for every queue message that appears in like a service bus queue, you can definitely do that. So 3 ways to kick off jobs.
Awesome. I think we're at time, but I'm going to just encourage people to keep submitting questions. There's another episode of this coming up soon, and we will have the replays ready for all of you. So thank you all for spending time with us. This was an awesome session. I love the demos. I want to come get the code from you, and hopefully we'll get more of our audiences using these features. Thank you so much for joining us on Ask the Expert, and we will see you at the next one.
That's good. Thank you so much.